Okay, welcome to this video. It's kind of weird because you want to be looking at this page, okay? This is the page you're looking at, but I like to talk and rant on other things at the beginning of my videos. So we're looking at notes that are, I think they're unit 6.3b. That's what this video is called. So unit 6.3b. And what we're trying to get done here is we're trying to, factor out the greatest common factor. That's what you saw in the last video, which was 6.2a, I think, or 6.3a. My apologies. And now here we're factoring simple quadratic expressions, which is 6.3b, and that's what we're doing right now. We might not get to solving simple equations or quadratic equations, but let's talk about what's happening here. This is a problem you know how to do. I like to call it a double distributive property or a FOIL. So what you're doing is you're taking the x and you're distributing it twice, and then you're taking the 2 and you're distributing it twice. And I think we know the answers for this pretty quick. If it's okay, I'll say the answer is x squared plus 8x, right? And then we change it over and we got plus 2x plus 16. So those are the answers to this question. And when we actually simplify it, we get x squared plus 10x plus 16. So the question was this with parentheses, and the answer looked like that. So the answer looked like that. So hopefully, if you give me a thumbs up or something like that, we understand how to do that type of stuff, double distributive, multiplying polynomials. Now I'm asking you to do it backwards. What if the question on your paper was the answer, and the answer on your paper was the question? How about that? So let's say this was the new idea. I want you to tell me what this breaks into. So the way you're going to do it is you're going to look for two numbers, listen closely, two numbers that multiply to this number right here, and they add to this number right here. So if you can think of two numbers that do that, you're going to be okay. And why is that? Well, here's what's going on. Let's look at a little bit of colors going on here. If we look at the purple x squared, we know that x, right, times x will give us x squared. Do we all agree that x times x will give us x squared? That's what's happening. Now the question is, what gives us 20? What multiplies to 20? So 2 times 10, 5 times 4, 20 times 1, but we know 2 and 10, right, are going to add the 12. So if I put down 2 and 10, and those are the numbers I use, I have to ask myself, do these also multiply to give me that? Yes. So we can see that 2 of our ribbons are good to go, right? So the question then becomes, what is the deal with that 12x? So I say to you, when I take the x and I multiply it by the 10, I get 10x, right? So we know we're going to get x squared. Everybody knows that part. That makes a lot of sense in the purple. And then we see the 10x coming through, and then we say, okay, well, what about this guy? That's 2x, right? And then everybody knows that this is going to come out to positive 20 right here, this loop. So the question becomes, what does that bottom of the screen simplify to? It simplifies to x squared plus 12x plus 20. So when we're breaking these things down, right, our answers are going to have two parentheses, okay? Don't forget, your answers will have two parentheses. So it's called defoiling. It's 6.3b, the unit. A quadratic equation is an equation with a power of 2. We learned about the names of types of equations. Quadratic has an exponent of 2, degree 2. This means that the highest exponent is 2, and we can factor them by slowly filling in what we know and using our thinking skills. So what I'm doing here is I'm looking at this first problem, this example right here, and I will literally highlight that for you. And I want to ask you if you can understand how that came out to what it came out to. Like, this all makes sense, right? So we distribute, we get x squared, we get 2x, we get 3x, we get positive 6. It simplifies to this problem right here, right here. But now the question is, what if you were given this problem backwards with different numbers? You'll notice that I switched the 6 and the 5 just to make the problem a tiny bit different. Well, if I was going to do this backwards, I would say, what multiplies to 5? What multiplies to 5 but adds to 6. Adds to 6. Because by the foiling, that's what's going to happen. We know x squared is just x times x, so that's that. So what multiplies the 5? Only 5 times 1, right? And 5 plus 1 is 6. So what we realize is that the things that multiply to 5 and add to 6 are 5 and 1. 5 plus 1 is 6. 5 times 1 is 5. Now to put a color to that, 5 times 1 is 5. That's your multiply, okay? And 5 plus 1 is 6. That's your add, this guy, okay? So let's try to think about that. Every time you need to ask yourself what numbers will multiply to the last number and add to the middle number if it's in the proper form. If we use the double distributive, will we get back to the original question? What if we use the double distributive property on this thing right here, x plus 5, x plus 1? You got to ask yourself, what does that come out to? Well, it comes out to x squared, I'm going to go quick here, plus x plus 5x plus 5. And we know x plus 5x is 6x, so we know that we have this as our answer. Does that look like the original question? Yeah. So we're doing these things backwards. Instead of doing the double distributive, we're doing the double distributive backwards. We're taking the answer from that and reversing it. Hopefully that is making some sense. We know that if we distribute out our answer to check it, we don't have to do that every time, we will have the right answer if it matches. Okay? Hopefully you have no questions and we're smooth here and we're good to go. Okay. So moving on, keeping this video as short as possible. Oh, excellent. Guys, it's time for your meme of the video. Just breaking things up here. What is love? Baby, don't hurt me. Okay? Yeah, it's pretty good. All right, well, it's a song. If you know it, you know, what is love? Don't hurt me, don't hurt me. Yeah, baby, don't hurt me. Yeah, exactly. So, what is love? Baby, don't hurt me. That's today's meme. Okay, hope you enjoyed it. So, this is what I want to do. Just go through a couple of these examples. So, you're asking yourself for two numbers that will multiply to what and add to what? They multiply to this guy. Multiply. Oops. Okay. Well, that's okay. Multiply. There we go. And they add to this. But let's use colors. Let's use different colors to do that. Okay, we're cruising through this video. This is great. What numbers will multiply and add? Well, what do we know every single answer is going to look like if we're doing the double distributive backwards, if we're doing FOIL backwards? Every single time the answer is going to have two sets of parentheses. So two sets of parentheses, and I ask you, first off, what will multiply to get me x squared? What times what? X times x. Exactly. So x times x gives you x squared. We need things that multiply to 8. So numbers that multiply to 8, just shout them out if you know them. Multiplies to 8. 4 times 2. What else? 8 times 1. Perfect. The question is, does 4 plus 2 equal 6, or does 8 plus 1 equal 6? 4 plus 2 equals 6. So we know our numbers, our magic numbers are 4 and 2. It doesn't matter whether it's 2 and 4 or 4 and 2, because multiplication order doesn't matter. So 4 and 2 are fine, and they're both positives. Don't worry, they're all going to be positive for now. So we look at the next problem. Let's go to the odds, and let's talk about those. Or maybe we'll go through all the evens even. So then it looks like the now you tries are on the bottom. So we need numbers that will multiply to 5 and add to 6. So I'm just going to put an A here for add and an M here for multiply. And I know that every single answer is going to look like this, two sets of parentheses. This is your basic factoring question, right? What multiplies to 5 but adds to 6? 5 times 1. 5 plus 1. So we know that our multiplication has to be 5 and 1 or 1 and 5. I put 1 and 5 just to show you that it doesn't matter if it's 5 and 1 or 1 and 5. Both answers are correct. Let's go to 3. What numbers will multiply to 3 but add to 4? 3 times 1. So we know that our answer is always going to look like this. These are actually equal. Why are they equal? Well, I'll show you. But we know that a times a is a squared, And we know that if we want it to multiply to 3, it needs to be 3 and 1. And hopefully, those two things will add to 4, and they do. So we're good to go. Okay? Now check it out. How do we know that this makes any sense? How do we know that those things equal each other? The way we know is by looking at the original problem, right, and the answer, and simply doing the distributive property. If we do the distributive property here, we get a squared plus a plus 3a plus 3. And that's a squared plus 4a plus 3. Does this look familiar to you? Does this look familiar to you? A squared plus 4a plus 3. Yeah, it should. It should look exactly like this. That's how you know it's right, because if you FOIL it out, if you multiply it, distribute it out, it will come out to the original question. You don't have to do that part every time, but you can. Lastly, we have to ask ourselves, what will multiply to? What will multiply to 21 and add to 10. Very good. So we're looking for things that will multiply to 21. It's okay. My studio audience here was a little shy to shout out the answers there. So we want to multiply to 21 and add to 10. So I think of numbers that multiply to 21, and I say, okay, well, my options are 21 times 1 and 7 times 3. Yes? What is 7 plus 3? Just so happens to be 10. So I can do x plus 3, x plus 7, or the opposite order. So here's how you can check yourself each time, okay? I wish, I wish I still had the giant foam finger, but I don't think I do anymore. No, that's too bad. So what I like to do is I like to look at the outsides and say, okay, well, see this is 7x and this is 3x. Do you see that? 7x and 3x is 10x. So when I do the OI of the FOIL, we'll be good to go. And obviously we know that 3 times 7 will give me the 21. So that's kind of where we're at. So hopefully this is a time where you can pause the video and give these two problems a shot. So take a second, pause the video, and give these two problems a shot. We're looking for numbers that multiply and add. We're going to open up with 2 sets of parentheses. And don't forget your variables. That's also a part of this problem. So we'll pause it, and I'll see you in a moment. So you've tried these two problems. Hopefully these are the now you try, now your turn, whatever you want to do, NYT. So you try 5 and 6 to get credit, okay? Now we continue on and we look at these challenge questions, and I'm going to help you out for starters. I'll give you a couple of these, and then the rest will be up to you. So 2 numbers that multiply to 4, but they subtract to 3. Well, we know that multiplying to 4, it can't be 2 and 2 because that's not going to subtract to 3. What will multiply to 4 also is 4 and 1. Those will also subtract to 3, agree? Yeah. So that's what we're doing. And then I say, what numbers will multiply to 12, but when they're subtracted, they give you 4? Does anyone want to jump in? 6. Numbers that multiply, yep. 6 times 2 is 12, and 6 minus 2 is 4. So 6 and 2 are your numbers. So this is going to be where we end the video and wrap it up. Hopefully it made a lot of sense. This is factoring. This is the big one. Pause the video and try these challenge questions, okay? And I think there are 10 of them perhaps or something like that. Well, only 8 actually. And I will see you in the next video. Peace.